All right, I think it's time. Welcome back to everybody. At the end of our first week, we are talking about DFAs. At least that's what I said at the very end last time. That's what I want to talk about today. And remember, DFA stands for, my pencils, deterministic, sorry, something's wacky. This, I may be running out of battery on my scribbler here. Well, I'm going to try to carry on. Sometimes my iPad overheats, and I take it out of the case, and everything's better. I'm going to try that. The deterministic finite automaton. Automata is the plural. I should probably say automaton. So remember, this we are going to call DFA. Oh, that looks better. And the words here, I gave a little description last time. Deterministic basically means that the machine doesn't have any randomness to it. When you give it the same input every time, it does exactly the same thing every time. It doesn't it doesn't like make a guess at any step or anything like that. Finite means that the machine has finitely many states, and this is kind of going to be a big deal when we draw these things out, when we write them down. Finitely many states. You can imagine this as like the machine can only be in finitely many different configurations as it's running. And then automaton is just kind of like the word we use for any kind of machine. The DFA, and remember the very basic structure of every machine we're ever going to talk about is it takes a string as input and then gives you some output. So a DFA is actually a little simpler than that, what I said might suggest. A DFA takes a string as input, but the output is not a string. The DFA is meant to be a very simple kind of a thing where instead of giving a string output, the output is just kind of like a yes or no. So it takes a string as input and either, I mean, you could say it says yes or no, but the terminology we use is it either accepts or rejects the string, all right? So you don't get a full string answer, you just get sort of like a thumbs up or a thumbs down answer, all right? Now eventually, later on in the semester, we'll talk about things which can give you another string as the answer, but we're going to talk about this kind of machine is just meant to accept or reject its input, all right? You could imagine that this is like some kind of a computer which just gives yes or no answers to questions, which is still quite powerful, right? So it either accepts or rejects the string. All right, it has finitely many states. And when we try to describe a machine like this, you know, you could try to describe in words exactly how the machine behaves, but the best way to describe these, so we describe a DFA using what we call a state diagram. I'm sorry, I meant to say another thing before I wrote that sentence. Can I squeeze something in right here? I'm just going to squeeze right in here. The DFA always, I just a little more specifically, it takes a string as the input, but the DFA is going to read the string one letter at a time, all right? And this is important in the way that we describe how it works. So the DFA reads the string one letter at a time. And the way that we do it, it's always going to read the string left to right, just like you would read a word in English. All right. And we're going to describe the DFA using a state diagram. The idea is the DFA begins in kind of like its default state, and then it looks at the first letter. And depending on what the first letter is, maybe it changes its state a little bit. in order to react to what the first letter was. And then it reads the second letter and then maybe changes its state again a little bit. And eventually it gets down to the end and then depending on what the state is at the end, it decides either I'm going to accept or reject the string. So here is a very simple example, and then we're going to do kind of, increasingly more interesting examples. But here is a very simple example. This I'm going to call an even length machine. I put an extra H in there. The idea is this machine is going to read a string, and then it will accept the string. This accepts if the string has even length, and it rejects if the string has odd length. All right? So it accepts if the string has even length, and rejects if the string has odd length. All right? This is the idea. This is what I want it to do. I want to describe exactly sort of like what are the various states, and then when the machine reads a particular letter, how does that decide how the state changes from one step to the next? This is what I need to this is what I need to describe. And now, since I'm only talking about the length of the string, actually this, I hope you will agree, has nothing to do with what the string actually says. Like, it doesn't really matter what the individual letters are. It's just, are there an even number of strings, an even number of letters, or an odd number of letters? So for this particular DFA, we'll use the alphabet. Like, it doesn't matter what the letters are, right? So we might as well use the alphabet. I will just call it A. Just A. Let's imagine that our strings here only consist of the letter A, all right? If they had other letters, it wouldn't matter, right? Because all this thing cares about is how many letters there are, not what the letters are. So they might as well all be the same letter, all right? So this is going to be our alphabet. All right, and here is our DFA state diagram. All right. The idea that I have in mind, I'm going to try and describe in words how the machine is supposed to work. It's probably not worth writing down all these words because the state diagram is actually much clearer. But the idea is when the machine begins, it's going to read the string, and depending on what letters it's seen so far, it's going to keep track if it's even or odd. All right. And when it starts, before you read any letters, that's like I read 0 letters. I'm gonna sort of pretend like, okay, what I've seen so far is even, because 0 is even. And then when I read one letter, if it was even before, that means it's now odd because I just added one more letter. But if it was odd before, then that means it's now even because I just added one more letter. And then you read the letters one at a time. You keep on flipping back and forth between even and odd. And then by the time you get to the end, if you finish off in the even state, then you say the string was even, and so it should be accepted. And if you finish off in the odd state, it should be rejected. All right, I'm going to draw a diagram which basically says exactly what I just said in words. So this one I'll call the even state, and this one I'll call the odd state. Each state is like a bubble. And then I'm going to draw little arrows which describe how the machine moves from one state to another every time it sees the letter A. So if I'm going to draw an arrow from here. If I'm in the even state and I see another letter, that means if, like, I used to think the string was even length, but then there's another letter that comes up, I'm going to go like so. And this is how we do it. I put an A there because that's the letter that I read. And if you think the string is even length and then you see an A, now you think the string is odd length, all right? And if you think the string is odd length and you see an A, then we should go back to the even state, all right? And this basically, this diagram does a much better job of explaining what I explained in about a minute's worth of saying words. This is what I was trying to say, all right? And this is how the machine acts. It has 2 states, and it moves from one state to the other according to this kind of rule here. All right, there are 2 little ingredients that we need to also specify here in order to fully describe what the machine does and how it works. The first is, what state do we start in? And I said this out loud. I said we should start in the even state. That's because when you start, it's as if you haven't seen any letters yet, and 0 letters would be an even amount. So we indicate that on the diagram with an arrow sort of like from nowhere into the even state. That indicates that the even state is where we start. So I'm going to try and like put some annotations here. So that little arrow there means this is the starting state. All right. And we should also indicate on the diagram somehow, how do you tell if the string should be accepted or rejected at the end? And what I said when I was describing this in words is, if we end up in the even state, it should be accepted. And if we end up in the odd state, it should be rejected. And the way we indicate that on the diagram is this even bubble over here just gets sort of like a double bubble, as they say. All right. So that kind of like double bubble thing here means this is what we call an accepting state. That means if the machine ends up in that state, the string should be accepted. And the other one over here, this is a rejecting state. And that means if the machine ends up in that state, the string should be rejected. All right. And this is my whole diagram. This is kind of like baby's first DFA diagram. This is a very simple example of a machine that does what I said. It reads a string of a bunch of A's, and it accepts or rejects depending on if the string had even or odd length. Anybody got questions about that? You can always sort of test it out. I suppose I'll write this down, but it's not going to look like much. Like, for instance, A. There's 5 of them. Here's how you test it out. You can kind of like do this with your fingers. I can only make one dot on the screen, but it's like I'm going to read through these letters one at a time and jump around the diagram. I start over here, and then I go A, and I ended up in the rejecting state, which means this string should be rejected. All right. Versus if it was AA, that means I start over here, I go A, and I ended up here, and so it should be accepted, all right? And that is, I mean, as with like real life computer programming, you should probably test out a few strings and make sure it really does what you think it's supposed to do. And you should test it out by just like running your finger around in the diagram a little bit. All right. This was a simple example. I got a few more, and then I have some for you all to try. Let's try. Maybe it's worth talking about the empty string. What about the empty string is always a good sort of sometimes weird special case that it's good to talk about. The empty string, if you were to test that out, you start over here and you just do nothing. And then you say, okay, I'm done. It should be accepted, all right? And that, I don't know if I said this specifically, but this actually is what you would expect to happen and what you would want to happen. The empty string has length 0, and 0 is even, and so it should be accepted, the empty string. All right, okay, how about, let's try, this is going to be a little fancier. And this, by the way, will be like your typical homework problems for the homework this week. Will be, just like this, make a DFA, and then I'm going to describe to you some which accepts some kind of a string, right? Let's say a DFA on the alphabet. This is going to be a little fancier. We got 2 letters this time. So this time when you read the string, it might have A's and it might also have B's in it. And let's do a DFA here which accepts strings with an odd number of B's and I'll just say any A's. Like the A's don't matter. But it has to have an odd number of B's and any number of A's. All right? Now, you have to kind of do a bunch of examples like this to get a feel for how to make these kinds of diagrams, but I'll give a suggestion here. Usually when you're talking about evens versus odds, you want to have that same sort of 2-state setup where you bounce back and forth. Now, we'll have to think about how do we handle the fact that I don't care about the A's, I only care about the B's, but I am still going to have this kind of 2-state setup here. And let's just say the one on the left is where I start, all right? And these 2 states are meant to keep track of evens versus odds as far as the B's go. It doesn't matter about the A's, but if I were to, could I just say one thing? I didn't say this specifically. I wrote these little words inside the bubbles. Those words are are not really meaningful. These are kind of like, I put them in there so that I could know what these two states are meant to represent. But those two words are not really part of what the diagram means, right? They are just my way of thinking about what those two states are. They are, I guess, in a real life programming language, you might consider these are like the comments. Like I called it even, but you don't have to really call them anything. But anyway, these two states, the way I'm thinking about them is the one on the left represents like even B's, and the one on the right represents odd B's, right? And I just don't care about the A's at all. You might think, do I need some states for the A's? But if you think about how this is supposed to work, actually the A's are kind of irrelevant in this. Like I don't really care about keeping track of the A's if they're evens or odds, because it doesn't matter. There could be any amount of them. So it turns out in this example we don't need more states than that. But anyway, I would think about from here, like where do the arrows go? Now if you're in this state, the next letter you see, it might be an A or it might be a B. So actually we're going to have two outgoing arrows here, one with an A on it and one with a B on it. All right? So what do you think? I'm going to draw an arrow with a B on it. I think that should go like this, right? If I'm in the first state, the one on the left, and you see another B, that means there used to be an even number of B's, but after I see the next B, now there's an odd number of B's. And what if I see an A in the state on the left? The way to think this through is if there's an even number of B's and then you see an A, where should I go over here or should I stay over here? These are your choices. If I see if I saw an even number of B's and then I see an A, does that mean there's still even number of B's or now there's an odd number? What do you say?
You should stay.
Yeah, stay on the left-hand side, and we indicate that like this, a little arrow back to itself. All right. If there's an even number of B's and you see an A, it don't matter. There's still an even number of B's. All right? And then from the other state on the right, we also need to see two outgoing arrows. And I think you can probably see where this is going. If there's an odd number of B's and you see another B, you should go over to the even side. And if there's an odd number of B's and you see an A, it doesn't matter. You should stay on the odd side. So this is our diagram of states. All right. I already said where the starting state is. You also need to indicate the accepting state, but this is easy. I mean, just remember what we're doing here. Accept strings with an odd number of B's. So the one over here is our accepting state. All right. This is how we do it. Any thoughts about that one? Questions about that one? So if I were to say test out something like BAA, BBA, so I start here. Of course, you always start in the starting state, and then I will say those letters and move my red dot. It's B, A, B, B, A, B. So it's over here. It should be rejected. And this does have an even number of B's, and it should be rejected. So I feel good about that. All right. Any thoughts about that? I got a couple more examples, and then I got two more, and then I have some for you to try. All right. These will take a little bit of getting used to. I think it's kind of like learning to write in a real programming language. Like you have to learn how to kind of think like the machine, and then you have to learn how to like express yourself in the language of the DFA, which is sometimes it takes some getting used to. All right, let's try. This is just another one where sigma is A, B. Most of our examples are going to be A's and B's. If you look at some textbooks on the subject, they always use 0 and 1, just like by analogy with real-life computers. It doesn't matter. You can call them A's, B's, or 0's, 1's. Anyway, I would like a DFA which accepts strings with no B's. That's it. It only accepts if there's no B's. If there is B's, it doesn't accept. All right, accepts strings with no B's. So this one is going to be different from the others. Like this is not about evens and odds. Like when if I'm reading the question and I see something about evens and odds, then I have in mind like two states which go back and forth from one to the other. This is not about that though. It's just no B's. All right. This one also, though, you can do with two states. Anybody have an idea for this? You have to tell me sort of like what your two states maybe represent or something. You got an idea?
No B's and B's.
Yeah, how about just two states where one represents there are no B's and one represents there are B's? I think I like this idea. Which of those would you say we should start in? I'll make the starting state on the left. That's how I usually do. Yeah, we should start in the no B's because when you're starting, it's like the empty string, and the empty string has no B's. So I'm going to start over here with no B's, and then this is the B's. All right. Someone else want to suggest which one should be the accepting state? We might as well do that first. Yeah?
No B's.
No B's, yeah, just because that's what I said. We should accept the strings with no B's. All right, so this is an accepting state. Now it's a matter of putting the arrows in, and you just have to think. So from the one on the left, where should the A arrow go? Should it go back to itself or across?
To itself.
Back to itself, yeah. If you have no B's so far and you read an A, then you still have no B's. So there's a A like that. But I think if we see a B over here, we should go over here, right? If you had no B's before, but then you see a B, then we got B's. Goes over there, all right? And then on the B's side, where do the arrows go here? So the A arrow, should I go back across or stay over here? What do you think?
Stay.
I think stay over here. If you've already seen some B's and then you see another A, it don't change the fact that I've already seen some B's. So believe me, I've seen some B's. Am I right? All right, and then from here also, B's. If I'm in the B's state, what if I see a B? I think also we should stay over here. Now you could draw another loopy if you like, although the way that we always draw it is like that. So if you have two edges, two of these arrows just like going the same place, we label them with we just write one of them and label it twice. That's just how they do it in our book. All right. And I think that's it. This is a DFA which accepts strings having no B's. Any thoughts about that one? All right, I got one more, and then I have some for you all to try. You can chat with your friends about them, or hide your paper from your friends if you don't want them to know. So again, this is, the alphabet is A's and B's, and I want to accept... This is kind of a combination of the previous ones. Any string with an even number of A's and no B's. All right. An even number of A's and no B's. At least just going by the words, this sounds like some kind of combination of the maybe the previous two ones we did, or something like that, a combination of some of the ones that we did. And it is something that we're going to talk about eventually in this class. Is there some kind of way to just like if I have, say, two DFAs like this, and I want to combine them using the word and, is there some kind of like operation that you can do just on the diagrams to glue these together? The answer is not exactly, but there are some things in that, along that idea that we are going to talk about eventually. But for now, let's just try and build this from scratch. An even number of A's and no B's. So this one, I'm going to need more than just two states. When I see these requirements here, when I see even number of A's, I think about, okay, there's got to be something that like flips back and forth. That's two states to keep track of that. But also to keep track of the fact that there's no B's, I think I'm going to need at least one more state. So here's my idea is, I'm going to have sort of two states which do some kind of a back and forth thing. I'm going to fill in the details later on. And then another state which keeps track of, do we have B's yet or not? And I think here, I'm just going to keep track of, if there's B's, you go down there, because that should be rejected no matter what. And if there are no B's, then we can do this back and forth thing. So I'm going to call these even A's, no B's. And this one is like odd A's, no B's. This is how I'm thinking about this. And then down there is just the B's. The B's is supposed to be rejected, and so it doesn't really matter what, I don't need to keep, you might think, do I need like even A's and yes B's? Odd A's and yes B's? That would work, but it's not necessary. Okay, let's try and fill in the arrows then. So I believe we should start here. That's because if we start with an empty string, that has an even number of A's, which would be 0, which is even, and no B's. All right, and to get the back and forth even odd thing, you need A's going back and forth like this. All right. What about the B arrow? Well, from the left state there, from the even A's and no B's, I think if you see a B, you should go down to the B's state. That's kind of the point of that state. And also, from the other one, if you see B, you should go down to the B's, right? That's what the B's is all about. I think we filled in all the arrows. Remember, every state needs 2 outgoing arrows, which we have for the first 2 states. The last state down there needs 2 outgoing arrows. Anybody want to say where they should go? Maybe someone I haven't heard from yet. I appreciate all the... Yeah, I think from this B state, it should go back to itself like so. Because if you've seen B's already, then if you see another A, you've still seen B's already. And if you see a B there, you've still seen B's already. All right? And that's a rejecting state. Where should my accepting state be? Even number of A's and no B's. That's this one here. All right? There you go. One thing, this is kind of like a common pattern that you will see in these DFA diagrams that you may recognize. This little piece right here, this is I would call this something like a permanent rejection state. We've all been there, I know that. Permanent rejection, all right? This is actually a helpful thing to keep in mind sometime, this sort of like pattern of drawing the diagrams. When I see this, one way of thinking through these words, even number of A's and no B's, I might think, well, as long as I'm reading A's, I go back and forth, evens, odds. But if I ever see a B, I should just go like to jail forever, right? Which is what this is. If I ever see a B, I go down here, and this state is going to reject no matter what happens. All right? This is how we do it. All right, I got some for you all. So I like to do this, ideally like at least once per class meeting. I'm going to give you some problems to work on. This is not like, I'm not grading them. You're not going to hand them in or anything, but I'm going to walk around and check in and make sure everybody's doing okay. So I hope that that's helpful. Feel free to talk to your friends about it if you like. So I would like you to try. These are 4 different ones. Can you believe it? Each time make me a DFA, and all of these I want the alphabet to be A's and B's. The first one accepts any string, starting with A. The second one, any string ending with A. The next one, any string starting and ending with A. See where I'm going with this? And then the last one, any string starting or ending with A. That's what I want. All right, see what you think. I will walk around and see how you're doing. Each time your answer just should be a diagram of something or other. I just wrote a little hint for the first one if you're having problems getting started. Ideas?
Because we don't want the first one. So if we did another,
I think
like, second
the first one actually
first
needs
one
3 states.
So we're gonna go here.
But that's a good idea for one of the states. The thing is, you can't make this the starting state because when you begin, like with the empty string doesn't start with it. So you don't want to enter the diagram right. There should be like another state, which is kind of like the welcoming room or something, and then from there you go to either one of those two.
What's the other, what's the other thing?
What would be the third state?
I think the third state is actually for either state. Because like,
I mean,
the way you drew it looks like maybe you're gonna start here, but actually you can't begin here because the empty string doesn't start with it. So you don't want the diagram to begin here. You want actually another state where it starts, and then it either goes to.
And also this gets another.
How's it going?
I think you did
This is pretty good.
So-
I would say
oh, but they only
you don't
read-
want that to be the starting
Yeah, also
state
you need
because
another
this will
state.
accept the empty string.
And then you have two
The empty string
actors.
doesn't
Oh, yeah.
start.
Oh,
So I would say keep this basic structure, but make make another state which is just like
And then I think it's A.
where you start, and then depending on what you see first, A or B, forks out to
Okay.
either this one.
So like, with the first stage, like, no, something like that.
Yeah, like it doesn't really matter what you call it, right? You
Okay.
can call it whatever. Yeah, it represents like you haven't seen anything yet, and then you focus.
Okay, well, and then like,
on
we
the
test one.
Okay.
That's the thing.
Oh, okay.
Because
I think you need
We'll just do B. Yeah, yeah, no,
say
we're
something
good.
about start?
Yeah, I think it's a label not starting.
Shaded circles.
It's just like automatic.
How's it going? Yeah. This is great. You need some arrows here.
Yeah. Okay.
How's it going?
This one, we wouldn't have anything
Still.
Well,
I think you have diagrams required to have outgoing arrows.
I know there would be no other.
And this is
Like there's no letters yet. Then like, okay, first letter.
Yes, but like for instance, if the string was
First letter
A, B,
doesn't start with
Yeah, it's like, it's not like.
no matter what it is, like from it is,
so there needs to be
and then
This one
this is like, oh,
this
it gets
is
A.
green.
It's supposed to be DA first. It's because kind of like the DFAs are in the string.
The first one, I mean, I guess,
I
it doesn't know how many seconds, like it's still starting.
It just.
Oh, right, okay.
It gets the.
Yeah,
But
right.
always had, I think.
How's it going? I like this. I mean, this would just be.
You would still go to start, and if it's an A,
Yeah. Well, I guess then.
you would definitely go there. You can see,
Yeah, 'cause I do have to.
you add another A.
Yeah, this
And then-
unfortunately will accept.
Okay, well then we just, you get another A,
B
go here,
should
you
go.
go here. And then you get,
If it gets
yeah,
the A again,
but it doesn't say. You another A.
So, actually,
Here, you get go
states.
here.
A and then
And then you get
B.
A.
One stage is just like
Say
the
that
sort of
one.
the welcoming room where nothing really happens.
A, B, it has
It
A
is
and
a
B
nice
stay.
thing.
No, I just.
How's it going here? Yeah, this is great.
Yeah, and then it's
That's
like-
perfect. Yeah. Get anywhere in the other ones? Oh,
So
just started.
yeah.
Okay.
And you send the B back, yeah.
How you guys doing? Yes? Yep.
Okay. Wait,
Yeah, you can have it.
so that's rejected. Yeah, we won't.
Yeah, think so.
Can I have a comment on the first one?
Yeah.
This one will accept engage.
This is where I remember seeing somebody doing.
Oh, wait, we should send that feedback.
Yeah, that's the thing. I think we just need to come back to.
Yeah, and then I think it's extra if you change that.
Yeah, because
Number
Okay,
So I think.
because it's just the letter.
Okay, so like.
Yeah, you said the same thing. This one actually needs.
For
three
this one,
states.
if you start with
And
B,
there should be. I like these the way they
Yeah,
are, kind of,
so-
but there should be, have like another state, which just goes into these two.
That's what I was trying to say. Depending on the first letter.
Either go,
So I'm going like here.
make a new state, and then if there's a, go to this one. If
Then it's
there's
gonna be a
no
first.
state,
This you just automatically. But when you start. Yeah, I think. It's included the A and the B. Yes. So then again, yeah.
But then I look at it and it reminds me.
Wait.
Oh, and then it's here.
I'm a little confused in the cycle. This last one it started at D, but
Yeah.
it's back, and then the A. Right now I have two states, but it very well could have third state. I'm just not aware.
Like, because you have to end here. So
Like,
it's
what do you
start
think?
there. So
Definitely,
Like, I don't think
well,
the A
it doesn't
goes
end
back.
with
To this one?
Yeah.
and ends with A.
Because if you start
That's what I have in my
with
two.
G,
How's it going?
no matter where you
I'm
put
thinking
it,
like it starts, it doesn't end with A, because it starts like it doesn't happen.
Yeah, there will be a lot of.
If it gets in there, it goes to right now.
Yeah, what I, you know what I'm saying? Yeah, what I.
It just stays, that doesn't end.
I think we could have.
So I think if we had A.
Then from ends at A, if it gets another A, it stays at A. But if it gets another A, it would return to doesn't end.
And then.
So then it would kind of keep that. So what do you do with the A's?
This would be A. Right.
Well, what the words you write don't really matter.
Yeah,
Problem is
That's
that
just kind of like your main state, but really what matters is.
We need like another one that looks like.
We need another.
We need one that looks like this.
Well, this is the.
So we need.
We have four.
We need.
This one, I would suggest you actually need.
Try to get like.
states.
Try to get like.
Yeah.
Try to make it
There
a.
should be one state,
Now the
which
last
you
letter.
just use at the beginning, and then
So
when you
then
see
if
that
it's
first
a
letter,
B,
it's an A, basically,
B,
the
and
first letter is
B.
an initial. Yeah,
B, right? So that's.
So yeah.
So this is, wait, this is the start A.
Want to make that first state, so the first.
Start A, I think.
Just we just need to get rid of.
Yeah.
Is this your,
And then if it's
there should be three
A.
states.
You can see my
Yeah, like,
response.
But, for B.
Like.
No, but we need this to.
Oh, we have it, and then this is done.
So Rob, so then now, if you have B, like as the first thing,
Right.
it'll come here,
Oh,
and then say it's gonna be A, or A, and then it's in.
Right. If
Or
it's
A.
and start with A.
And now,
then it
A.
just automatically.
So this
matter
state
what,
comes
it's
in,
gonna be
started with A, is that?
Yeah.
Then you should start on that, because when you begin the whole process.
You have no.
So there should be another state.
So then I think this
That's
one is
when you first
also
begin.
gonna make four,
And
but
then
I
if
think
they're,
if you like.
start with A, you can go into this.
I'm a sophomore.
Start with B.
So here it is.
How's it coming on here?
I think I understood.
I like that.
And the second one, having more than two states is pretty cool.
Yeah, you moved in two states.
That's what I
You basically got two-thirds.
How's it coming?
Yeah.
Three states.
Well, I think that's how it's
You need three states, there should be three.
I think we have to start with really
those circles, for example. And
And
when you start off, it's because when you start off, you don't know if it started with an A or a B yet, because you didn't see it.
Well, the reason I realized that
So there should be one state. If you see A first, then you can make an arrow
Oh, we
that
can do multiple than
you see a
nine.
B first. And you
But
can
maybe
make
it's
an
just starting where maybe we just go back.
That's my idea.
Okay, well, here's what happens. So we do A.
All right, I think we should talk about these because we only got 10 minutes left. This is probably more than we could bargain for. Like I don't expect that you actually did all 4 of these, and if you haven't finished them all, that's totally fine with me. Most people figured out the first one at least. Any string starting with A. So I don't know if my words here were very helpful. I thought they were going to be helpful, and then nobody seemed to be very inspired by what I said. So maybe it was confusing the way I said it. I said, depending on the first letter, either go to a permanent failure state or a permanent accepting state. What I had in mind, so this is the starting with A. Oh no. Starting with A. What I had in mind was, when you begin, the starting state, I don't know if it started with A or not. Like, I didn't see any letters yet. See, the first sort of mistake that I saw, many people started off by saying something like, I will start off in this state where it starts with A, but actually you don't know if it starts with A when you first begin. So don't call this anything. You could call this like the the waiting room. Like when we begin, actually we don't even know what the first letter looks like at all. But if it's an A, then I'm going to go over here to an accepting state because it started with A, right? And this one, if it starts with A, I don't really care what happens after that. I know that it started with A and it should be accepted. And that's why this needs a little something like this. All right? So if the string started with A, you go up here, and then no matter what happens after that, it should be accepted. And then if it starts with B, I go down here, and no matter what happens after that, it should be rejected. This is what I was trying to say when I say, what did I say? Depending on the first letter, use a permanent failure or a permanent accepting. This is like a permanent accepting state. No matter what happens here, it will always be accepted. And this is a permanent failure. No matter what happens, it will always be rejected. All right? I hope this makes sense to folks. Any questions? Yeah?
So, like, the first, like, circle you did that you call, like, the waiting room, like, you can just start, like, with, like, nothing in the box, basically?
You mean no little words here?
Yeah.
Yeah, I mean, the little words are not really part of the diagram. They are just for myself to remind myself of what that's supposed to represent. So if I really wanted to give this a label, I would say something like this. You could say this represents the empty string. Like this is where you
Just like a
start
start.
before you saw anything. Yeah, but I mean, you could call it like you could put a little smiley face in there if you want. Like you can write whatever you want inside there. It doesn't matter. Yeah, I would, if you want to think of this as just like this is some sort of starting state, which is not very descriptive at all. But I don't know what I'm going to do next, but you have to start somewhere. All right, and you can't start here. That's the point, because if you start here, then you will be accepting the empty string, which you don't want. All right. Okay, that is starting with A. What about ending with A? Actually, this one, you only need 2 states. And I saw some folks ended up with this. So the 2 states are just, does it end with A or not? So here, and where do we begin? You should think about the empty string. Does the empty string end with A? It does not. So I'm going to start in a rejecting state, and this is not ends with A. Sorry, I didn't fill in. Maybe I should write the words bigger. Although the words are a bit of a red herring because, like I said, the words don't really matter. But not ending with A is my starting state because the empty string doesn't end with A. And now, if the string so far does not end with A and you see an A, that means actually now it does end with A. So I'm going to do a little something like this. Ends with A. Once we're all sort of pro gamers at this, I'm not even going to write the little words inside of the states. I mean, the words inside of the states are to help you understand what you're doing, but they are not actually important, like logically part of the machine. Anyway, if it was not ending with A and I see A, now it is ending with A. This should be an accepting state because that's what I said. We should accept when it ends with A. Now, what about the A arrow here? If it ends with A and then you see another A, then it still ends with A. But if it ends with A and you see a B, now it does no longer ends with A, right? So you should go back there with a B. And then we also need a B arrow here. If your string is not ending with A and then you see another B, then it's still not ending with A. So it's like this. And this is what I had for my answer. It is possible that you drew a larger, more complicated diagram that's still correct, although probably, if you got it right, it's probably this. And if you didn't draw that, it's probably not quite right. Any thoughts about it? All right. Yeah, we got 5 minutes. Let's just do the other two. Okay, starting and ending with A. That was the next one. Starting and ending. This one also I used, actually I used 4 states when I did this. Did anybody do it in less than 4 states? Any got an idea? You want to try and tell me what you had?
I have an empty, or the
A rejecting state?
rejecting state,
Yeah.
empty set, and then,
Oh, this represents the empty string?
yeah.
Okay, yep.
And then starting with A and ending with A,
Okay.
and then A does not start with A or does not start with A. Or does not end with A.
Okay, so we have a state here which represents starts and ends with A, right?
Yeah.
Okay. And I guess you have an A going like that.
Yeah.
And then you have another state which is it doesn't start and end with A.
It doesn't start with A or does not start, does not end.
Yeah, right. That's what I meant. So this is doesn't start with A or doesn't start with B.
Doesn't
not-
start
With A, yeah. Or it doesn't end with A. Huh. Sorry. These are hard to say out loud. Actually, I'm not sure I feel too good about this. But, no, I think this will work. So where do the arrows go?
And then there's a B from the end. Yeah.
Like that? All right.
And then a B from the start and end with A down.
Okay, a B like that. I think an A like this.
Yeah.
And
And then A or B.
yeah, there is something that is this what you had? Yeah, there's something that I don't quite like about this. Anybody have feelings about this? Yeah? Yeah, I think this one rejects A, B, A because it goes A, B, and then A will end here. I assume you meant this should be the accepting state, right? Yeah. Yeah, this will go A, B, A, and reject here, but we actually don't want that. Anyone else had an idea? I think when I did this, I used 4 states. I don't know if that's strictly necessary. Anybody? I saw somebody nodding. Did you have an answer for this one? You want to try?
We did 4 states. We did the like empty one and then start and end with A, and then we had to start with B1 and then end with B.
Okay, I think I might like this better. Thank you, by the way, for the first suggestion. So you had 2 other states.
Yeah, the one right there would be start with B, the one next to it.
Okay.
And then there would be another one that's end with B.
All right, and that's kind of up here, right?
Yeah.
Okay, so I would call this one starts with A and ends with B. Is that what you meant by yeah? Yeah, I think this is how you need to set up the diagram. This starts with B thing should be rejected no matter what because I have to I have to accept when it starts and ends with B. Starts and ends with A. So if it starts with B, it should definitely be rejected. But then if it starts with so if it's starting and ending with A and you see an A, it now goes here. But if you see a B, it can go here, and then it can go back here with an A. So this extra state here allows you to go back and forth. You can see a B from here, but still get back to it and accept eventually, which is the issue with the previous version of this diagram. Yeah, I think that's good. Sorry, we got to go now. So let me just write down the answer for the or. Starting or ending. At least this is how I did it. Of course, there are probably other ways you could do it. If it starts with A, then immediately it should be accepted no matter what. If it starts with B, then maybe it's going to be accepted because if it eventually ends with A. And the way to make that happen is like this. So this says if it starts with A, it should definitely be accepted no matter what. But if it starts with B, we need to see an A, and then it should be accepted. If you see a B again, you need to get another A on the end before it should be accepted. So this is the starts with A or ends with A. Yes?
There should be a B going in on itself on the bottom state, right?
Yeah, I have no outgoing B arrow here. It should be like this. Thank you. Yep. All right. You will have homework problems like these. It'll be due on Wednesday, and I'm going to post the assignment on the class webpage sometime this afternoon. So check it out. Hope you all have a good weekend. Stay safe, y'all.